6.3 Operations with radicals. In this section, we're going to go over how to combine radicals, meaning adding or subtracting, and also how to multiply radicals. And at the very end of the section, we're going to learn how to rationalize the denominator and also simplify. Let's start with the first example. And we also want to notice that we are assuming that all variables represent positive numbers. Let's take a look at the first example. So let me make a quick modification. Index here is actually 3. Okay, so our index is 3. If we want to add and subtract radicals, we need to make sure that we have the same index. So all of these have an index of 3. And we also need to have the same radicand, meaning whatever's inside of the radical needs to be exactly the same. At this point in time, we do not have like radicals because we have different numbers inside of these radicals. This one's 81, 48, 24. So what we want to do is look at this problem and see if we could simplify each radical, and then maybe at the very end we would have like radicals. Let's start with the first example. So if you remember from before, 81 is not a perfect cube, but you can rewrite 81 so that we have a perfect cube times a number that we can't simplify. So let's see. This can be rewritten as cube root, and we can write 81 as 27 times 3, and then x squared. 27 times 3 is 81. 27 is a perfect cube, so I take the cube root of 27, but we're going to leave 3 on the inside of the radical because we can't take the cube root of 3. We also need to leave x squared because this exponent 2 is less than 3, so we leave x squared inside. Next, we have minus 5, and we're going to write this as cube root. And then 48, we can actually rewrite that as 8 times 6 because 8 is a perfect cube. Minus 5 cube root, okay, 24. The best way to break down 24 so that you have the largest possible cube root would be 8 times 3. We take the cube root and simplify each of the 3 radicals. Since we have 5 here on the outside, when you take the cube root of 8, that's 2, we have to multiply it with 5. And so eventually this will be 10. Cube root of 6x squared minus 5. Again, cube root of 8 is 2. Everything else stays inside the cube root. All right, I'm going to multiply those 2. Okay, so now we look for like radicals. The first and the last are like radicals because they have the same index and the same radicand. The middle radical does not have 3, it has 6. And so this, we have to leave this second radical alone. Just combine the first and the third, and the way you combine is we just work with the numbers on the outside. It's going to be 3 minus 10, and we leave the radical the way it is. We do not add inside the radical. We leave it the way it is. So it's just 3 minus 10 is negative 7 cube root of 3x squared. Leave the radical as is. We only change the number in front. These two are the only numbers that we combine. Bring down the second radical. This is our final answer. Second example. In this case, we are going to go over how to multiply. So this is a binomial. It's 2 terms. And remember, if you have a binomial squared, the way that we multiply is we need to FOIL. And so we write 2 exact copies of our binomial. And then we just FOIL. So we have the first terms, square root x times square root x is square root of x squared, plus square root of x times 3 square root of y gives us 3 square root of xy, plus these two, we get the same exact, plus the last 2 terms, 3 times 3 is 9 times square root of y squared. Let's simplify. Square root of x squared is just x. I know x is positive, so we just write x, plus we have 2 like radicals. Remember, you only add the numbers in front. 3 plus 3, that's 6. Bring down the radical. Then we have plus 9y. And that is our final answer. Okay, the last part of this section asks us to rationalize the denominator and simplify. And again, we assume all variables are positive. To rationalize the denominator, it just means to eliminate the square root in the denominator. So when we have a fraction, we would like to write our answer with no radicals in the denominator. Okay, there's a couple ways to simplify these and to rationalize. One thing that we can do is we can just take a look at this denominator, and you want to ask yourself, square root of 6 is not a perfect square. However, we can multiply by a factor of 1, so we don't change the value. What happens if you multiply what you're given by square root of 6 over square root of 6? This is just equal to 1, and so 1 times anything doesn't change the value. Let's see what happens. We're going to get square root of 84 over square root of 36. This is a perfect square, so I can take the square root and the square root goes away. So I have rationalized my denominator. I have 6, I don't have a square root, so that's great. Now, square root of 84, we can simplify that. And if you look at the number 84, the best way to break down 84 is to write this as 4 times 21. 4 times 21 is the same as 84, and we take the square root of 4, and that's going to be 2 on the outside. Leave 21 on the inside since we can't do anything with it. And the last thing we can do is reduce 2 and 6, and so we get square root of 21 over 3. This is one way to rationalize and simplify. Another thing you could have done is you can actually reduce 6 and 14. So you could reduce first and then multiply by whatever is needed to get a perfect square in the denominator. That will also work. Let's look at second example. This is a cube root, so I need to get a perfect cube in the denominator. So let's see what is it that we could multiply by. How do I get a perfect cube? 2 times what is a perfect cube? 4. 2 times 4 is 8. That's a perfect cube. And y to the 4th is not a perfect cube because the index 3 doesn't divide 4. But how about we write y squared, and 4 plus 2 is 6, and 3 goes into 6, and that is a perfect cube. Let's multiply. We get cube root of 28xy squared over cube root of 8y to the 6th. The whole idea here is to try to get a perfect cube, and this is a perfect cube. You just need to figure out what to multiply by to get a perfect cube. Numerator, we can't simplify, just recopy it. And the denominator turns into 2y squared because we take 6 and divide it by the index, so squared. And that's our final answer. And really quick for example C, you're going to multiply by the conjugate of the denominator, which just means you switch the sign. And you need to FOIL in the numerator and FOIL in the denominator, both places. Let's see what we get. FOIL in the denominator and things will actually simplify nicely. If you FOIL this out, the 2 middle terms go away, and so we're really just left with square root of 36 minus 9. When you FOIL this out, we're just left with the first and the last term. Let's simplify this really quick. So we take the square root of 36, that's 6. And then we combine our like terms, and if we do that correctly, we're left with negative root 6. This is 6 minus 9, so that's going to be negative 3, and our final answer is root 6 over 3. And notice that you cannot reduce 3 and 6 because 3 is not inside the radical. So this is our final answer.